Welcome back, guys, and in this video we're diving deep into DaVinci Resolve's project settings. To access the project settings, you need to go to DaVinci Resolve's main menu, then go to File, and then select Project Settings. Or you can click on the gear icon in the bottom right-hand corner of the interface. Once you have project settings open, on the left-hand side you'll see a list of categories. The first one, and the one that we're focused on today, is Master Settings. This is the foundation of your entire project, so getting these right from the start will save you a lot of headache down the line. Let's break down the first section, Timeline Format. In this section, the first thing you'll see is Timeline Resolution. When you click that drop-down, you'll see a list of common presets, everything from 720p HD all the way up to 8K and beyond. Your timeline resolution should match your final delivery resolution. If you're delivering a 1080p video, set this to 1920 by 1080. If you're delivering 4K, leave it at 3840 by 2160. If you're working on vertical content for TikTok, Reels, or Shorts, you'll want to use the vertical resolution option. Directly underneath the dropdown, you'll see two fields you can edit titled For Processing. These fields let you monitor your selected resolution, but they let you enter custom resolutions if none of the presets fit your needs. Below this, you've got a checkbox labeled Use Vertical Resolution. This is the toggle you want to enable when you're cutting vertical content. Think Instagram Reels, TikTok, YouTube Shorts, or any other 9:16 format. When this is checked, it swaps your horizontal and vertical pixel values. This is a simple but powerful toggle for short form creators. Next up, you'll see Enable Apple Immersive Workflow. In our screenshot, this option is grayed out, and that's because Apple Immersive Video is a very specific format designed for the Apple Vision Pro headset. So unless you're shooting video for the Vision Pro, you can safely ignore this setting. Our next section is Pixel Aspect Ratio, and you'll see four options here. The first one is Square, and this is what 99% of you should be using. Modern digital video uses square pixels, meaning each pixel is a perfect 1:1 ratio. This is the default for HD, UHD, 4K, and pretty much any digital workflow. Next is 16:9 anamorphic, and this is used when you're shooting with anamorphic lenses that squeeze a widescreen image onto a 16:9 sensor. The pixels are non-square and need to be unsqueezed during playback. After that, we have 4:3 standard definition, a legacy option for working with old standard definition footage like DV tapes or old broadcast material. And finally, CinemaScope, used for ultra-wide cinematic aspect ratios, typically 2.39 to 1, where the image is squeezed during capture and stretched out for projection. Now we get to one of the most important settings in your entire project, timeline frame rate. Here's the key thing to understand. Once you import media into your project, the timeline frame rate becomes locked. You can't change it after the fact without creating a new project. If you've already added media, you'll notice this drop-down is grayed out, and that's a really important detail to understand. So before you start importing footage, decide what frame rate you'll want to work in. Next is Use Drop Frame Timecode, and this is only relevant for specific frame rates like 2997 and 5994. Basically, frame rates that don't divide evenly into whole seconds. Next is Enable Interlace Processing. Interlacing is a legacy video technique used in old broadcast formats where each frame is split into two fields. Modern progressive video doesn't use this, and unless you're working with old DV, HDV, or broadcast tape footage, you can safely leave this unchecked. Then we have Align Clips to Frame Boundaries. This is checked by default, and I recommend that you leave it that way. It makes sure all your clips snap evenly to the whole frame positions on the timeline. Next, we have Playback frame rate. This is the frame rate at which your timeline plays back in the viewer. One thing to keep in mind is that the settings you choose here in Project Settings are your default settings for any new timeline you create. So this means that each individual timeline can have its own resolution and aspect ratio. Just keep in mind, frame rate is the one exception. That's locked at the project level. So every timeline in your project runs at the same frame rate. Let's say your main format is long-form 4K horizontal YouTube content. Every new timeline you create will inherit those settings by default. But what if you wanted to take a clip from that long-form video and cut it into a vertical short? You don't need to create a brand new project. You can just simply do the following. In your current project, go to the Edit page, right-click in the Media pool, and choose New Timeline. In the Timeline Creation dialog, uncheck Use Project Settings, then manually set that new timeline to whatever resolution you want. Now you've got both your long-form 4K horizontal timeline and a vertical short timeline living inside the same project. Alright, now that we've locked in our timeline format, let's scroll down to the next section, Video Monitoring. The video monitoring section is primarily designed for editors and colorists who are using external monitoring hardware. Specifically, Blackmagic Design's own products like the Ultra Studio, DeckLink, or Mini Monitor devices. These let you send your video signal out via SDI or HDMI to a calibrated reference monitor, which is essential for professional color grading. So let's break down the first one, video resolution. This controls the resolution of the signal being sent out to your external monitor through your Blackmagic capture device. In most cases, you'll want this to match your timeline resolution, so what you see in your reference monitor matches what's actually in your project. Right below this is format, and this is the frame rate of the signal being sent to your external monitor. And just like the video resolution, you typically want this to match your timeline frame rate, so playback on your reference display is accurate and in sync with your timeline. If there's a mismatch here, you may see stuttering or frame drops on your external monitor, even though your timeline is playing back perfectly inside of Resolve. Next, we've got a checkbox for Use 444 SDI. This refers to chroma subsampling. So 422 is the standard for most broadcast and professional video. It compresses color information to save bandwidth. And 444 sends full color information with no compression. Every pixel has its own complete color data. Enable this only if your external monitor and your SDI capture device both support 444. Then we have Use Level A for 3GB SDI. This is a very technical broadcast setting. If your gear specifies Level A, then check this box. Otherwise, you can leave it unchecked. Next is Use Dual Outputs on SDI. This option lets you send two separate video signals through your SDI ports. Now we get to SDI configuration, which has three options. The first is Single Link. This sends your video signal through a single SDI cable. This is the most common setup, and it works for most resolutions up to 1080p and some UHD signals. Next is Dual Link, and this splits the video signal across two SDI cables, which is necessary for higher resolutions or higher bit depths that exceed the bandwidth of a single SDI connection. And finally, Quad Link. This splits the signal across four SDI cables, typically used for 4K UHD and higher resolutions at higher frame rates or in 444 color. Choose the option that matches your monitor and capture device's input configuration. If you're not sure, check your hardware documentation. Next, we have data levels with two options. The first selection is video. And this uses the standard broadcast range where black is at code value 64 and white is at 940 in 10-bit. This is the correct setting for almost all standard video workflows. It matches what broadcast monitors expect. The second option is full. This uses the full data range where black is at 0 and white is at 1023. If your blacks look gray or your whites look blown out on your external monitor, this setting is usually the culprit. Next is retain sub-black and super white data. In broadcast video, anything below code value 64, sub-black, or anything above 940, super white, is typically clipped. Checking this box preserves those values when sending it to your external monitor. Next is video bit depth. This controls the color depth of the signal being sent to your external monitor. So 8-bit gives you 256 shades per channel, which is standard for consumer displays. 10-bit, which gives you 1024 shades per channel, and it's the professional standard for color work. And then we have 12-bit, which gives you 4096 shades per channel, and this is used for high-end cinema and HDR mastering. Then we have monitor scaling. This determines how Resolve scales the image when the timeline resolution doesn't perfectly match your monitor's resolution. Bilinear is faster and slightly softer at scaling and good for real-time playback. Bicubic is higher in quality, but with slightly more processing overhead. For most workflows, bilinear is fine. If you're doing critical evaluation and need the sharpest possible image on your monitor, switch to bicubic. Next is use Rec 601 matrix for 422 SDI output. This is a color matrix conversion option. If you're outputting standard definition content to an SDI device that expects Rec 601, then check this box and select Rec 601 from the dropdown. And finally, we come to Enable HDR metadata. This embeds HDR metadata into your SDI output signal. This is essential when you're grading HDR content and you need to send an accurate HDR signal to your reference monitor. All right, now we're getting into one of my favorite sections, and honestly, one of the most underutilized sections for a lot of editors out there. This is optimize media and render cache. So our first setting is proxy media resolution. Proxy media is a lower resolution copy of your source footage that Resolve generates so you can edit smoothly, especially when you're working with heavy codecs like RAW, B-RAW, ProRes, or high-resolution 6K or 8K footage. And your options typically include original, half, and quarter. Now, original gives you full resolution proxies, which defeats the purpose for most workflows. Next is half, and this is half the resolution of your source, which is a good balance between quality and performance. And then we have quarter, and quarter resolution is best for heavy footage or underpowered systems. So for most workflows, half is the sweet spot. You get a noticeable performance boost while still seeing enough detail to make good editing decisions. And next we have proxy media format. This determines what codec Resolve uses when generating those proxy files. ProRes 422 is the industry standard, and it has great quality and excellent performance, but it does come with a larger file size. ProRes 422 LT is a lighter version with smaller file sizes, but it's still very good in quality. And then we have ProRes 422 Proxy, which is the smallest ProRes option designed specifically for proxy workflows. Next is Optimize Media Resolution. Now, this is where people often get confused. What's the difference between proxy media and optimized media? Well, proxy media lives in a separate file next to your original footage. You can toggle it on or off, take it offline, and even relink it later. Optimized media is managed inside Resolve's cache. Resolve creates it to turn heavy or unsupported codecs into something that plays back smoothly. And you can also drop this down to half or quarter if you need more performance. And next is Optimize Media Format. And this is the codec used when generating optimized media. ProRes 422HQ is a higher quality variant of ProRes 422. It's slightly larger in file size, but better for color reproduction and has less compression. It's a great choice for optimized media because you want that media to be high quality. Then we have Render Cache Format. The render cache is what Resolve uses to pre-render sections of your timeline that have heavy effects, color grades, or composites, so they play back in real time instead of grinding to a halt. So choosing ProRes 422HQ here gives you higher quality cache files that look great during playback and review. But if you're tight on disk space, you can always drop this down to ProRes 422 or 422LT. Next, we have Enable Background Caching after 5 seconds. And this is another one of my favorite features. When enabled, Resolve will automatically start caching your timeline after it's been idled for a specific number of seconds. Next, we have Automatically Cache Transitions in User Mode. When this is checked, Resolve will automatically cache any transitions you add to your timeline. Next, we have Automatically Cache Composites in User Mode. And this is the same idea, but for composites, things like picture-in-picture, multi-layer stacks, blend modes, and so on. Essentially, anything that requires Resolve to combine multiple video layers will get cached automatically. And then we have Automatically Cache Fusion Effects in User Mode. So anything you build in Fusion, titles, VFX, complex compositions will automatically be cached when this is enabled. Next up is the Working Folders section. And this is where you tell Resolve where to store all the files it generates during your project: proxies, cache files, gallery stills, and your project media. This section is critical for organization, performance, and disk management. The first one is Project Media Location, and this is where Resolve will store any media that's directly tied to your project. In this example, you'll notice that the path is on an external Samsung RAID 0 drive, and you would want this so that your project media is on the fastest external storage, not your system drive. And RAID 0 specifically gives you maximum speed by stripping data across multiple drives, which is perfect for video editing. And this is actually part of a larger storage setup I built using the TerraMaster D4 SSD NVMe enclosure. And if you want to see exactly how I built that setup, I've got a full video breakdown on the channel, and I'll leave the link in the description down below. And next is Proxy Generation Location. And this is where Resolve stores those proxy files we talked about earlier. Since proxy files can get really large, especially on big projects, you definitely want this on a fast drive with plenty of space. Then we have Cache File Location. And this is where all your render cache files live. Every time Resolve caches a section of your timeline, those files get written here. And keep in mind, cache files can grow huge over time, especially on long projects with lots of effects. And then we have Gallery Still Location. And this is where Resolve stores still grabs from your color page gallery. Just one thing to note, that the .gallery folder is hidden, and this is by design. Resolve manages those files internally, and you generally don't need to mess with them manually. And the last section under Master Settings is Frame Interpolation. This controls how Resolve handles speed changes when you slow down or speed up clips in your timeline. The first one is Retime Process. This is the algorithm that Resolve uses when you change the speed of a clip, and you have 3 options here. The first is Nearest, and this is the simplest method. Resolve just duplicates or skips existing frames to achieve the speed change. It's the fastest, but it can also look choppy on slow motion. Next is frame blend, and Resolve blends the adjacent frames together to create smoother motion. It's better than Nearest, but it can look slightly soft or ghostly. And then we have optical flow, and this is the most advanced of the three. Resolve actually analyzes the motion between frames and generates brand new in-between frames to smooth things out. And next is motion estimation mode. This works hand in hand with retime process when you're using optical flow. And here are your options: standard better, enhanced faster, and enhanced better. And then we have Speed Warp, which is a Resolve Studio exclusive. It uses the DaVinci Neural Engine and AI and machine learning to analyze motion. It produces incredibly clean slow motion, but it's the most process-intensive option. And finally, we have motion range. And this tells Resolve how much movement to expect in your footage when calculating motion-based interpolation. And your options here are small, medium, and large. I think one important clarification on frame interpolation in project settings is that it's the default behavior for your entire project, and that you can and absolutely should override these settings on a per clip basis in the edit page or the color page. And this is exactly why the project level setting is usually kept on something fast like Nearest, because it's the global default. And if every clip on your timeline was being processed by Speed Warp, it would definitely make your machine unusable. And that's it for the master settings section. Get these dialed in from the start, and the rest of your project runs a whole lot smoother. If you found this helpful, be sure to hit the like button and drop a comment down below. And don't forget to subscribe. Thanks for watching, guys, and I will see you in the next one.